Let's try the systems word problem. The cost to insure jewelry is a fixed amount, F, plus a percentage, P, of the value of the jewelry. It costs $32 to insure $1,000 worth of jewelry. So the cost, C, is 32. The cost is 1,000 P plus a fixed cost. P is the percentage. The percentage of the cost of a jewelry is P times 1,000 because that's $1,000 worth of jewelry, and we're paying a certain percentage to insure this jewelry plus a fixed cost, and the overall cost is $32. This here is our first equation. Let's try our second. The cost, $44.50, is 3,500 P, a percentage of this more expensive jewelry, plus that same fixed cost. Given two equations and two different unknowns, P and F, we can solve for both P and F. Let's solve F. We can use elimination, and we can subtract the bottom equation minus the top. So what's 4450 minus 32? We have 12.5 equals 2,500 P, and the F's cancel out. Dividing both sides by 2,500, we have P equals 0.005. Multiplying by 100, this means 0.5%. This is less than 1%. Let's substitute this p-value into this first equation up here. 32 equals 1,000 P, which is 0.005, plus F. We can multiply 0.005 by 1,000 by moving the decimal 3 to the right and canceling out these three zeros. So we have 5 plus F equals 32. Thus, F equals 32 minus 5, which is 27. So we solved the problem. The fixed amount is $27, and we pay this amount regardless of how expensive or cheap the jewelry is. Let's try a mixing systems problem. How many ounces of 20% hydrochloric acid solution and 70% hydrochloric acid solution must be mixed to obtain 20 ounces of 50% acid solution? Let's let X be the ounces of the weaker acid, whereas Y represents the stronger acid. The easier equation is these two ounces sum to be 20. So X plus Y equals 20 ounces. The weaker acid plus the stronger acid has to total this amount. In order to make the second equation, we're going to really focus in on the amount of acid only. 20% means 0.20 and 70% means 0.70. We know the volume of the weaker acid is X. So if we focus on an equation involving only pure acid, 20% of X represents only the acid found in this weaker solution. And we add a certain percentage of Y, which is 70%. 70% of Y represents only the acid found in this solution, equals, when we add some pure acid with some more pure acid, we know that we're going to have 20 ounces of something, but not at 100%, at a concentration of 50% of 20 ounces. This here is the mixed solution. So equation number 1 is easy to reason. Equation number 2 takes a bit of focus, but if you focus on setting up an equation involving pure acid only, You should be able to remember this. The rest is algebra. We can either use substitution or elimination. Let's isolate for y. Y equals 20 minus x. And we'll plug this in, substituting into here. We have 0.20x plus 0.70y, which is 20 minus x, equals 0.5 times 20, which is 10. Let's multiply both sides by 100. So the decimals are promoted to the right 2 units. We have 20x plus 70, 20 minus x, equals 1000 because we move the decimal 2 to the right. We carry on with algebra. 20x plus, using distribution, we have 1400 minus 70x equals 1000. 20x minus 70x is negative 50x. We'll throw it over, so we have 50x on the right, and 1400 minus 1000 is 400. Dividing both sides by 50, we have x equals 8. So we now know that we need 8 ounces of the weaker acid, this 20% acid, to form this new solution. Now let's find y. We plug in x equals 8 into equation number 1. 8 plus y equals 20. Thus y equals 20 minus 8, which is 12. So we also need 12 ounces of the stronger acid, which is at 70%. This mixing problem is very important for nurses as well as pharmacists.